Okay, so we've got a moment question here. So we're looking at forces. A moment's a turning force. So we're looking at a force that's going to turn something around. And if we look at the question, there's a post, and we've got the forces. We have a quick check. We are looking at newtons, so we don't have to worry about kilonewtons, and we're looking in meters as well. So we haven't got any fancy units we have to worry about. It's just newtons and meters. And if we slide this down, it's asking us to work out the turning moment of this rope at hole A. And we know that a moment is going to be force times the distance to the pivot. Okay, and we can see from here that if our force is 300, our distance to the pivot is 0.8, so it's simply going to be 300 newtons multiplied by 0.8 meters. So if we plug that into our calculator, we're going to find that's going to come to an answer of 240. It says give the units, so we're looking at newtons and meters, so it's just going to be straight newton meters. Then they attached a rope to hole B. Again, we're looking at meters, 1.68 meters above the ground. They're pulled with a horizontal force. What force would produce the same turning force? So it's the same turning force. It's still producing 240 newton meters. But now that's going to be equal to the force, which we don't know, multiplied by the distance. Our new distance is 1.6 meters. Okay, so we need to do 240 divided by 1.6. Okay, we put that into the calculator and we've got force is 240 newton meters divided by 1.6 equals 150. Now it's asking for a force, so that's going to be in newtons. Okay, so that's how you would approach a problem like this. There is another way of looking at it. You've got a force of 300 newtons, 0.8 meters away from the position of pivot. Our second time we're doing it, the distance has gone twice as big. This is twice as big as this. So if we're getting the same turning force, if we're going twice as far from the pivot, we'll only need half the force. And that's what we've got, half the force, 150 newtons.